Welcome to the lecture. Today we are going to see the problems on per unit calculations. Now see the example. Determine the generator voltage for the given system. In this system, here we are having a generator connected with the transformer that is connected through transmission line to load. The rating of the generator is 85 MVA, 10 kilovolt, and the subtransient reactance is 0.65 per unit. The rating of transformer 40 MVA, 10 kilovolt bar 210 kilovolt, and the reactance is 0.2 per unit. Then the impedance of the transmission line is J120 ohm, which is connected to the bus 200 kilovolt. And that bus connected with the resistive load, that is R equal to 550 ohm. For this given system, we have to draw the reactance diagram by assuming the base values of 120 MVA and 200 kilovolt on transmission line. So in this system, they are asking us to take the base values on the transmission side. So now we have to find the reactance of each and every component to draw the reactance diagram. Now let us find the reactance of the transmission line because they are asking us to take the base values on the transmission side. So first one is reactance of transmission line. So when we go for reactance of transmission line, first we have to determine the base impedance. So the formula for base impedance is ZB equal to KVB squared divided by MVAB. So in this problem, the given base voltage is, so for us, if you want, we can note it that KVB new equal to 200 kilovolt. MVAB new equal to 120 MVA. Now, from this base value, we want to determine the base impedance. So, KVB value is 200. So, 200 square divided by MVA value is 120. So, based on this, we can simplify the value. ZB equal to 333 ohm. Now we have determined the base impedance. We want to determine the per unit value of the transmission line. So the formula for per unit value of the transmission line is X per unit transmission line equal to actual impedance by base impedance. So the actual impedance of the transmission line is given, that is 120 ohm divided by the base impedance is 330 ohm. So that if you simplify this, X per unit transmission line, we will get J 0.36 per unit. Now the transmission line is connected at transformer, so that we have to determine the reactance of the transformer. So either for transformer, either we can calculate on high voltage side or we can calculate on low voltage side. So here the transmission line is connected on high voltage side, so we can take high voltage side as the reference. So the reactance of transformer is, the formula for reactance is X per unit transformer is equal to X per unit volt into KVB volt divided by KVB new the whole square into MVAB new divided by MVAB volt. So whatever the values they have given for this component, that is old value. Now for this transformer, here they have given the value of the power is 40 MVA and the voltage is 10 kilovolt bar 210 kilovolt. Now we have taken from the transmission line side, so that we have to take high voltage side as the reference. So the old value for the transformer is 210 kilovolt. So we have to substitute. What is the per unit reactance of the transformer given is, that is old value. So the old value of the reactance is 0.2 per unit, and the kVb old on high voltage side is 210 kilovolt, and the kVb new is 200 kilovolt. So kilovolt become cancelled, so no need to substitute here. Into MVAB new is 120, MVAB old 40. So if you simplify this, we can get the per unit reactance of transformer. So if you simplify the above value, we can get the per unit value as 0.6615 per unit. Now we have to calculate the reactance for generator. Reactance of generator. But in this problem, the generator is connected at low voltage side. So we have to go for the voltage conversion. So formula for voltage conversion is base kV on LT side equal to base kV on HT side into LT voltage rating divided by HT voltage rating. So here this HT and LT voltage rating we have to take the from the transformer. So what is the HT rating and LT rating is given for the transformer, that is 210 kilovolt and 10 kilovolt. So that we have to substitute here for that LT and HT rating. So now the base kV on HT side we have taken it as, which is taken from the transmission line, that is 200 kilovolt into LT voltage rating is 10 kilovolt and HT voltage rating of the transformer is 210. Now if you simplify this, we will get the base kV on LT side. So if you simplify this value, we will get the base voltage as 9.52 kilovolt. Now we have to use this value for determining the reactance of generator. So formula for determining the reactance of the generator is X per unit generator equal to X per unit volt into kVb old divided by kVb new the whole square into MVAB new divided by MVAB old. So this is the formula which you have to use for all the component for determining the reactance. So from the given problem, the per unit reactance value of the generator is 0.65 per unit into kVb volt. The voltage rating given for the generator is 10, and the new value which we have determined is 9.52 the whole square into MVAB new is 120, MVAB old is 85. Now if you solve this value, we will get X per unit generator, that is 1.012 per unit. Now at last we have to determine the reactance of the load. Reactance of the load. So here the load connected to the 200 volt bus is resistive load, so that we have already calculated the base impedance for the transmission line, so we can use the same base impedance for load. So the base impedance for the transmission line is 333 ohm. The same base impedance we can use here. So X per unit load equal to actual by base impedance, that is actual impedance of the load is 550 ohm and the base impedance is 333. So the X per unit value of the load is X per unit load equal to 1.6516 per unit. Now by using all this reactance value, we have to draw the reactance diagram. Reactance diagram. So now we have determined the reactance for the generator, that is EG. Reactance for the generator is 1.012. So X per unit generator. Now the reactance of the transformer is J 0.6615 per unit, and for transmission line is J 0.36 per unit, which is connected at bus. From that bus we will have a resistive load, and the per unit impedance of the resistive load is 1.6516 per unit. Now still the problem is not completed. They ask us to determine the generator terminal voltage. So at load bus we have to calculate the voltage drop. So at load bus we know that the per unit value of the voltage is V per unit is equal to 1 per unit, and R per unit value is, we have calculated, that is 1.6516 per unit. From this we have to calculate the I per unit. So as per the Ohm's law, we know that I per unit is equal to V by R. So V per unit divided by R per unit, that is 1 divided by 1.6516. So I per unit is equal to, we will get 0.605 per unit. Now by using this current value, we have to calculate the generator voltage. So now voltage drop in the network is, here we are having the reactance of the generator, transformer, transmission line, and the load we are having the resistive load. So from that we can calculate the voltage drop. So that is equal to I per unit into R per unit plus J into X per unit generator plus X per unit transformer plus X per unit transmission line. So now by substituting all those values, we can calculate the voltage drop. I per unit value is 0.605, R per unit is 1.6516 plus J, X per unit is 1.012. Similarly, for transformer 0.6615, and for transmission line 0.36. Now, if you simplify this equation, we get 0.605 into 1.6516 plus J 2.034. Now multiply this and convert this rectangular form into polar form. We will get 0.605 into 2.619 into, sorry, 2.619 at an angle 50.92. Now multiply this and we can take the voltage magnitude, that is 1.584 at an angle 50.92 per unit. So from this they are asking us the actual generator voltage. So the actual generator voltage equal to V per unit into base voltage. So the base voltage on the generator we have determined as 9.523 kilovolt. So that we have to multiply with this magnitude of the voltage. This magnitude of the generator terminal is 1.584 and the base voltage is 9.523. If we multiply that, we will get 15.093 kilowatt. So this is the actual generator voltage which we have determined from the reactance diagram. Thank you.